Okay, guys, so now we're going to take a look of equations with variables on both sides when we have special solutions, okay? So let's look at this first problem. 10x plus 12 equals 2 times 5x plus 6. So we're going to go ahead and draw a line. And we're going to look at the right-hand side, 10x plus 12. Do we have anything to distribute or any like terms to combine? No. So I'm going to go look at my right-hand side. And I do see something that I need to distribute, so let me do that. 2 times 5x and 2 times 6. So that gives me 10x, and that gives me plus 6. And I'm going to rewrite, that is actually, my bad, I didn't actually do my multiplying. That is a 12. So then on my right-hand side, I have 10x plus 12. So if you notice, and then bring down my equal sign, these are the same equations whether on the right or the left. Okay, so there's nothing to simplify on either side, but we're just going to go and solve it. So I'm going to subtract my 10x on both sides. I know it cancels out on the left. However, it also cancels out it cancels out on the right, it cancels out on the left. So I'm going to bring down my 12, and I'm going to bring down the 12 from the right. 12 equals 12. That is always true, and this is what we call a special solution, and that answer is all real numbers. So what that means, is that no matter what value I get for x, it will always create a true statement like this, and so the answer was all real numbers. So any number I can possibly go and think of is going to fit in there for x, and it's going to give me a true statement. So all real numbers is the answer. Okay, let's go over here and let's look at this equation. 9m minus 4 equals negative 3m plus 5 plus 12m. So we'll draw a line, and if I look on the left, I see there's nothing to distribute, so I'm just going to put my 9m minus 4. Now, I look on the right, there is nothing to distribute, but I do have two like terms here and here, so I need to combine them. So negative 3 plus 12, have your calculators handy, that gives me 9m, and I have plus 5. So we should notice that you have 9m on the left and 9m on the right. So that should be an indicator that when you see that there's something special, that's going to happen. So I'm going to move the 9m. It really doesn't matter because they are exactly the same. Do the inverse operation and subtract in 9m from both sides. So when I do it from the left, that cancels out. I get negative 4. When I do it on the right, it cancels out, and I get 5. And so now it tells me the statement of negative 4 equals 5. And we know that's not right. That is never true. There's never an instance where negative 4 will equal 5. It's never true. So we call that special solution. That is a no solution. There is no value for x that I can plug in, or for the variable m. No value I can plug in for the variable that will give me a true statement. Okay, so no solution. All right, so we're going to try it down here. Just try it some more. Make sure we get the hang of it. So on the left, I have something to distribute. 3 times 4b minus 2 equals negative 6 plus 12b. So 3 times 4b, 3 times negative 2. 3 times 4b is 12b. 3 times negative 2 is negative 6, equals negative 6 plus 12b. So this is written a little different, but we should notice that these are essentially the same problems. You have two positive 12b's on the right and the left, and then you have negative 6 on the right and the left. Okay, but we're still going to solve it. We want to go do our due diligence, make sure we get things correct. So I'm going to subtract 12 from both sides, 12b. Those cancel out. I get negative 6. cancels out on the right, and I get negative 6. Negative 6 equals negative 6. Is that a true statement? Yes, it is. So this solution is all real numbers. All right, and so we look at this last problem. 2x plus 7 equals negative 1 times 3 minus 2x. All right, 2x plus 7, that's as simple as you're going to get. So let me go look at the right-hand side. Negative 1 times 3, negative 1 times negative 2x. So 2x plus 7, we know that's right. Now let me distribute. Negative 1 times 3 is negative 3. Negative 1 times negative 2 is a positive 2x. So when I look on the left and the right, I should see that I have a positive 2x on the left and a positive 2x on the right. That lets you know something special. Okay, so something's different is going to happen with this problem. So I'm going to go and do my inverse operation so I can get all my variables on one side. That cancels out to 0, and this cancels out to 0. So I'm left with positive 7 on the left and negative 3 on the right. 7 equals negative 3. Is that a true statement? No, it is not. So the answer is no solution. That is something that is never true. 7 equals 7. Okay? 7 is never the same as negative 3. So that is no solution. So we want to think about, are there some rules or something that we can go and follow when we're looking at equations, okay, that have no solutions? What's some type of rule we can go and write for that? So we're going to think when the coefficients of x match, and so we'll say that means the variables disappear. And the resulting statement is false. So you will get no solution when the coefficients of x match. So when your coefficients are the same, but the resulting statement is false. Like this here is a false statement. This here is a false statement. So when your coefficients match and it creates a false statement, that is no solution. So then what about when you have infinitely many solutions? Okay? Well, it's kind of the same. When the coefficients, let me get this. When the coefficients of x match, and so then the variables, I didn't need that. So when the variables disappear and the and resulting statement is true. So when it is a true statement, the coefficients match and they cancel each other out, but you have a true statement such as negative 6 equals negative 6 or 12 equals 12. When you wind up with those type of true statements, it is infinitely many solution, aka all real numbers.